There are a couple of things we'll be looking at in this video. The first is whether a function shows exponential growth or decay, and the second is we'll be exploring a couple different ways to graph an exponential function. Now, before we can identify whether a graph shows exponential growth or decay, we have to identify what a and b are. Now, in this problem, we can see that 1.5 is what our exponent x is attached to. Well, that means that b equals 1.5 in this case. Now, it initially appears there isn't an a value, but if there isn't an a value, then that means it must just be an invisible times 1 out front. In other words, our starting value is just 1. Well, b is 1.5, which is greater than 1, which means that this must show growth, exponential growth. Now, the first way we're going to look at graphing these is by filling in a table of values. Now, this could be useful if you were, for example, asked to draw a sketch of a graph by hand. You're still going to have to use a calculator to fill in your table because it's going to get difficult rather quickly to figure out what 1.5 to the x is. And we'll pick some easy values, some easy numbers that include negative numbers and positive numbers. So here's a table that's filled in for x from -2 up to +4. Now to sketch our graph, we're just going to go ahead and plot those points. So when x is -2, y is 0.4, that's right around there. -1, 0.7 is right around there. 0, 1. So again, we can notice our y-intercept is 1, which is the same as our a value that we found earlier. When x is 1, we get 1.5, 2, we get 2.3, 3, we get 3.4, and 4, we get 5.1. And we can again see that familiar curve that we saw in our examples in the last video, and hopefully you're better at drawing these than I am because that was pretty bad. But you want to try to connect your dots as best you can with a relatively smooth curve, and that will be good enough. Second way I want to look at graphing these is if you just need a graph to look at to figure out some values or just to see what the general shape looks like. So again, first thing I'm going to do though is identify if this is growth or decay. So we can first of all see the thing that is being raised to the x power, our base, is 0.8. And our a value out front in this one is 30. Well, again, all we are interested in is that b value for growth or decay. So in this case, it's 0.8, which is between 0 and 1, which means this is going to be decay. So the second way to graph these, though, is simply to use your graphing calculator. If you want to do that, you're going to go back to y equals, the same place that we're used to typing in these functions if you want to look at the graph, and you're going to type in 30, and then you hit times, which will probably fill in one of those little asterisks, and then 0.8. It's usually beneficial to put that in parentheses actually, so 30 times parentheses 0.8 close parentheses. And then we're going to raise that to the x power. So to type that in your calculator, you'll have to use the caret feature. So caret x. That's what it should look like roughly on your graphing calculator. And if you then go to your graph, you can adjust your window. In this case, I used a minimum y value of -10, a maximum y value of 30, minimum x of -5, and maximum x of 25. And then we can see our nice, smooth, exponential decay curve like we expected.